Thank you for watching Mr. B's Auto Shop. Today we are going to cover a simple circuit and the four-step process to diagnose an electrical fault. First off, simple circuit. All circuits must contain the following items. First, some type of power source. On your car, that would be a battery. On your house, that would be the wall outlet or the power line coming into your house. We then need some type of conductor to go to the circuit and a conductor to return to the battery. Whatever power comes from the battery must return to the battery as well. So if 2 amps flows out of the battery, then 2 amps will return to the battery through the negative side. In this case, we have a controlled simple circuit. It is called a controlled simple circuit because it includes a method of controlling it, which in this case is a switch. It also contains a circuit protection device, which is the fuse, and an electrical load, which is in this case a light bulb. So we will go ahead and turn the circuit on, and you see this circuit works perfectly. If the circuit is working perfectly, you're not the smartest person in the world if you're testing it. Normally, when we test the circuit, it is because there is a fault. Here we have the same circuit. I'm going to go ahead and turn the circuit on, and you'll notice the light does not illuminate. So we are going to use the four-step process of diagnosing any electrical circuit. This is the four-step process. Oops. All right, step one, we call it V1, measure source voltage. So we're gonna go ahead and do that. It does not do you any good to diagnose a circuit if there is no power. It's kind of like when you call the computer hotline, hey, my computer doesn't work. The first thing they're always gonna tell you is the computer plugged in? And then you respond with, oh, never mind, and hang up on them. First, we determine the expected voltage. This is a 12-volt circuit. I should have 12 volts present. You will notice that I have 12.03 volts. If this is not what you expect, then you need to check the battery or the power source because you have a problem with the power, not with the circuit. Once we've done that, we are now going to move on to V2. V2 is measuring voltage drop of the load. Like I mentioned earlier, the load is the electrical device that does the work. So I'm going to measure voltage drop. So I'm going to place the positive lead on the input to the light bulb, and I'm going to place the negative lead on the ground side of the light bulb. And if the meter reads less than 0.3 volts, you have not found the problem, and we can see the meter reads 0. However, if the meter reads 12 volts, the load is bad, and we'll cover that in a little bit. So we haven't found the problem yet. We are now going to measure V3. V3 is voltage drop of the ground side. So I'm going to go from the output of the light bulb to the battery ground. Sometimes you'll be tempted to just go to chassis ground. But if you do, you may bypass the problem. So always go to the battery ground or a known good ground. If the meter reads source voltage, then the problem is in that area. If the meter does not read source voltage, then you're going to move on to the next step. We're now going to measure V4. V4 is voltage drop of the power side. So we're going to measure the entire power side. So we're going to place our red lead on the battery positive, and we are going to place our black lead on the input to the load. If it reads 0, then you've done something wrong, because this is the last step and you should have found the problem by now. If it reads source voltage, like ours does, this indicates the problem is in the power side. So we're now going to separate each component till we find the source voltage. So first we're going to check this wire. If it reads less than 0.3, we have not found the problem, and that's 0.3 volts. This reads 0.0, so we have not found the problem yet. I then am going to go across the fuse. When I go across the fuse, you will notice that it reads 12 volts, or source voltage. So that tells me the problem is between these two leads, which is the fuse. So I'm going to go ahead and remove the fuse, turn the circuit off, replace the fuse. If I can get it in there. And now the circuit works, and you'll notice I have 0.05 volts or 52 millivolts. So you can see how quick and easy we could diagnose for a bad fuse. Next, we are going to look at a different problem. So now we have the circuit. As we can see, the light does not illuminate. So we are going to follow the same 4 steps. That is all you need to diagnose a DC electrical circuit. If you follow these 4 steps, you will find the problem every time very quickly. So we are going to start out with measuring source voltage. We're looking for 12 volts. I have 12.03 volts. That indicates the power source is acceptable. The next step, voltage drop of the load. If voltage drop of the load is equal to source voltage, you have a faulty load, or it is on. We can clearly see it is not on, so we are going to replace the load. It's always better to turn the circuit off when you're replacing the loads. That way you don't take a chance of damaging the circuit or yourself. And you'll see by simply replacing the light bulb, we have fixed the problem. Next, we're going to have a different problem. We have our circuit. You can see that the light does not illuminate. So we are going to run the 4 V's. First step, measure source voltage. It should be what you expect. In this case, we expect 12 volts. You can see that the meter reads 12 volts. So the power source is good. V2, voltage drop across the load. If it's less than 0.3, then we have not found the problem yet. If it's equal to source voltage, the load is bad, replace the load. In this case, it is 0 millivolts, which would definitely be 0 volts. We have not found the problem yet. Next, we're going to measure voltage drop of the ground side of the circuit from the ground of the load to the battery. If it reads 0.5 or less, then that indicates that we have not found the problem. If it reads more, or source voltage, then the problem is on the ground side. We'll notice that it reads 12 volts, which means there's no connection between the battery and the load. I'm then going to break down each part of that circuit. So I'm going to measure from the battery ground to the ground of the board. And you'll notice that it reads 0.1 millivolts or 0.001 volts. So we have not found the problem yet. I then am going to place the lead on the ground we just tested, and I'm going to go to the ground of the load. You'll notice it reads source voltage. So the wire is faulty. We're going to go ahead and replace the wire. Turn the circuit off, then replace the wire. And you see the circuit now works. So by using the steps V1 through V4, it's pretty simple to diagnose any problems. If V2 is within 0.5 volts of source voltage, replace the load. If V3 or V4 is greater than 0.3 volts, then you're going to measure voltage drop of each part to pinpoint the issue. When you have a measurement that shows 12 volts or source voltage, the problem is between the 2 meter leads. So this concludes our basic controlled simple circuit and the use of the V1 through 4 to diagnose the circuit. In the next lesson, we will cover a series circuit and the steps to diagnose that type of a circuit. Thank you for paying attention and following Mr. B's Auto Shop, and I will see you the next lesson.